calculating specific heat for processes. In this problem, it says the specific heat of solid iron is 0.450 joules per gram times degrees Celsius. A 31.0 sample of iron is heated to 974 degrees Celsius and is placed in 200 grams of water at 25 degrees Celsius. How much heat is gained by the water, assuming no heat is lost? And here is the specific heat of water. So for this problem, what we have to understand is that negative Q iron, I'm going to write negative Q iron like this. What this tells me is that this is also equal to the energy that is going to be gained. So here we have this energy and the energy that's going to be gained by water, the heat that's water is going to get. So that is going to be our Q of water. So we can use Q equals mc delta T for both of these equations to figure out what the temperature, the final temperature is going to be. So we have a final temperature, and what we need to realize is that the final temperature is going to be the same for the system. So from Q iron to QW, we're going to have the TF is going to be the same for both. It's going to be the same for both. So what we're going to do then is, since these are equal, we're going to compare them. We're going to put negative 31.2 grams, which is the mass, times 0.450, which is the specific heat, times the change in temperature, which is TF, minus 974 degrees Celsius. So that's what we have for iron. And I put negative there to show that it's losing its heat and it's giving it to water. And water is going to gain that, so it's going to have 200 grams times 4.18 times what we're going to have TF minus 25 degrees Celsius. So TF is going to be the same. So when we solve for TF, what we're going to see is that TF is 40.7 degrees Celsius. And from there, now we can figure out the heat that is gained by water by doing the specific heat equation. So for Q of water is going to equal 200 times 4.18 times we have here TF, which is going to be 40.7 minus 25.0 degrees Celsius. And when we do this, when we calculate this, what we're going to see is that we get 13.1 kilojoules, or 13,100 joules as the answer to this problem.